Hello, 2100. Today we get to do the conservation of linear momentum lab. And what we aren't going to do is use the air tracks, which is lucky for you because that involves the spark tape. And you should be familiar with that system. You've used it before in the semester. It involves segments of tape with multiple little tick marks on them and meticulously measuring their location, then plotting it, then finding the slope of your curve to determine the velocity. And it's time consuming. That system does have advantages. Friction is extremely negligible. So if you were to set the cart in motion, it would travel across the entire length, which is about 4 meters, and oscillate back and forth, and very slowly would it lose its momentum. With the Pasco Smart Cart, we really can't go those distances. Friction does play a role, and it does lose energy and in effect momentum as the cart travels. But the advantage of this is that the software plots its velocity quite accurately. You don't need a great distance of travel as you do in the air tracks to even out the errors associated with those dots. So what we'll do is 3 separate runs. One of them, or the first 2 I should say, are collisions where these 2 carts will collide and stick together. One will be stationary. There's 2 different trials because we're going to use different masses. And with the last experiment, it'll be an explosive one where the carts are tied together while they're being repelled with opposite poles of the magnet. The string will be burnt or cut, and hence the explosion. So what we're going to do is impart a force on this red cart, set it in motion so it'll have some initial velocity. It'll collide and stick with the second blue cart, and the 2 stuck together will have a final velocity. If you recall, I didn't give the red cart that much of a push. In fact, after they stuck together, they came to a halt relatively quickly. In fact, it was about 3 seconds. See up here? They're stationary, is indicated by this flat line. What we're interested in is the point where they made contact, so we can determine the velocity immediately before and immediately after. Obviously, from the blue cart, you can see it was at rest up until about 19.25 seconds when it was struck. Then it was given some velocity here. And this point at 19.25 seconds corresponds to this point here on the red cart. That is the moment in time it made contact with the blue cart. So let's find its velocity just prior to the collision. .3893 meters per second. And just after the collision, 0.1855 meters per second. If we were to find the velocity of the blue cart at this same instant in time, that would roughly correspond to that data point. And you could see it's only off by about 2 thousandths of a meter per second. So these 2 values can be used then for the velocity of the system before and after the collision. So this is part 1B, where we make this rider more massive And we'll do the same thing, impart a force on the red card so that it collides and sticks on the blue card. So here's our data for that last run. For the first 14 seconds or so, the cards were at rest. I put my finger on the red card at this moment in time. That's why you see a little bit of movement there. But what we want to focus in on is this highlighted area, because of course the collision took place right around 15 seconds. So after zooming in, you can see that a collision took place in between this time interval. Actually, between these 2 points. So that is the initial velocity of the red card, prior, of course, to the collision. And immediately afterwards. And you can see that they're the same velocity. I mean, it's off by, again, about 1/1000th of a meter per second. Here's the third part of the experiment. It is called Arrangement C in your lab manual, and it's where two riders of unequal mass are tied together, and what is going to happen is that they're going to be repelled from each other by those two magnets after I burn the string. As a side note, this isn't going to be dramatic. So here we go with the third part. And here's the data from the last arrangement. And after about 10 centimeters, you can see that the blue cart actually came to rest, whereas the red cart traveled about 30 centimeters. Both short distances for sure, but that isn't going to concern us, because immediately after the collision, before the carts had much of a chance to lose momentum, we were able to determine its velocity. So let's zoom in on that portion of the graph and determine their individual velocities. So there, the velocity of the blue cart is 0.1006 meters per second, while the red cart is 0.1649 meters per second in the opposite direction. You can see one slope would be positive while the other one is negative. So as we were going through the experiments, I didn't report to you the masses of the carts being used. I did, however, put them on a scale on my own time. So you have their masses recorded here, and the velocities taken from the Capstone software. All right, 2100. Until next time, see you guys later.